Hello and welcome to a special edition episode of C++ Weekly. I will be airing this outside of my normal weekly schedule, probably tomorrow morning at the time of this recording. But I just recently learned about NASA and the JPL, Jet Propulsion Laboratories library called F Prime, which is a flight software and embedded systems framework that is used as one of the pieces of software that is used in the Mars lander that just made it to Mars yesterday. This is part of the 2020 Mars expedition. This has a rover and a helicopter. And the helicopter, Ingenuity here, is the thing that is making use of this F Prime software library. So I learned that F Prime is used in it, and F Prime is at least partially written in C++. And if you follow this channel, you know that sometimes I like to do reviews of C++ software on here, and I thought, what the heck, let's give it a shot. Let's do an exploration and review of some of the software that's open source that was used on a mission to Mars that just landed February 18th. I'm recording this on February 19th. Now, wherever I can, I will be referring back to notes from my C++ Best Practices book that I recently released, which is available here on LeanPub, and it is also available on Amazon if you prefer a print copy. Now, keep in mind, if you go to buy a copy of this book, that it is very short. Actually, it's intentionally quite short because I wanted to make the rules and examples as succinct as possible. I've learned as a contractor and a trainer and someone who does code reviews that people don't really read a lot of text. You can give them a lot of information, they're not going to read it. I wanted to make things simple and then give you a bunch of resources to follow up on. So just so you know, that's what you're going to get if you buy a copy of this book that I'm going to refer back to. Now, on the LeanPub website, we actually have a table of contents here. And it's the table of contents and these numbers that I'm going to be referring back to if and when it makes sense to while we're reviewing this code. Now, I don't know. I've only given the code a cursory glance so far. I don't know if I'm going to have a lot of things to point out about it. And even if I do, let's be fair, this is code that has successfully flown on another planet. Now, I haven't written any code that's done that, at least nothing as far as I know. It's possible some of the open source stuff that I've worked on has ended up somewhere that I don't know about. So, we're going to just explore this code. We're going to look at it. I don't expect to find anything crazy in here, but let's see what we do find. Now, if we go to the GitHub project page, and this is NASA/F Prime, the first thing that I noticed is that it does have on this lgtm.com website a code quality for C and C++ code of an A. Well, that sounds good. Let's go ahead and click on that. Now, I do notice that this is an A when compared to other C and C++ projects. That immediately makes me go, okay, I don't know how bad are the other C++ projects. So if I scroll down here, I see most of the C++ projects, unfortunately, get like D's and C's in here. So that's not good. But let's just go ahead and click on and see why only an A, what issues does it have? And if let's see, I don't care about security. I want to try to look through the C++ code specifically. Okay, so it looks like it's got it's showing 3 tags here. Assignment does not return this. Declaration hides parameter and large parameters. So if I scroll over here, I can see, okay, there's a couple of alerts. It looks like there's only 2 files with alerts using the search criteria that I've given it. File downlink.cbp. And it has in here the parameter of type source file name string is 112 bytes. Consider passing by const pointer or reference instead. And I don't know, it's taking this thing by copy in its constructor. Let's see. And then, well, this looks like we're declaring a C style struct. This looks interesting. I'm not sure, honestly, what I'm looking at here. It's doing a mem copy of the source file name into this entry object of source file name. All right, so yeah, this is very interesting that it's doing a direct mem copy of this thing, of the two cars. So hopefully that's something safe to do. Why they're taking this thing by value, I was looking for maybe they're doing the copy and move idiom kind of thing. I don't see anything like that here. It makes me wonder what exactly is the nature of this code. We see C style cast and whatever down here. And this is a .cpp file. So I don't know, maybe we should just dig into the code directly. But it looks like, I mean, if I'm reading this right, LGTM seems to only have 3 different things that it can search for. I don't know, because I'm not seeing alerts for anything except for those 2. And why did it give me 3 different warnings to look at? So, all right, let's go to the source code. Entirely possible. I just don't know how to use this LGTM website effectively. All right, so we've got, let's see, a docker, we've got git ignore, okay, CMAKE list. Let's see, there's a CI subfolder. Let's look at this real quick. It's got clearly some sort of CI that's running here. PyLlama, that does not look like a C++ CI. And these tests, just build just this framework and then just test to prove that it works. Okay, so it's got some sort of continuous integration available to it and some bash scripts for it. I'm not directly, let's see, there's a .github file. Aha, .github actions. There's a GitHub CI action. Runs continuous integration testing on F prime with a Docker and a Docker file. So it looks like they've got some sort of Docker testing going on here. Okay, so that is, just for the record, one of my main points in my book here, that you definitely need to have continuous builds of some sort. It looks like they have some kind going on. Although I don't see any kind of dashboard or current build success, anything listed on the README here. There was a commit 3 hours ago. Actions, let's see what our actions are. Okay, so we definitely do have CI running on each of the pull requests. All right, very good. So that's the top thing here. I'm going to click on the CMAKE list. I'm going to zoom in maybe a little bit more here. CMAKE 3.5, whatever. We see that they're doing a lot of variable management here. So they're doing -w all -w error. That's a good start. It's should be your absolute bare minimum amount of warnings and errors, warnings that you have. -w all is, well, -w all is like nothing. Let's see. We enable -w all in this particular project as a canary to warn about compilation errors without impacting real projects where a warning from an untested compiler could break the build. Okay, so yeah, -w all is like absolute bare minimum. And then we see that they actually go in and disable no string op truncation globally. And again, using the CMAKE C flags and CMAKE CXX flags, as opposed to using the target level CMAKE things. So we have target compile options. Now, if they were using this higher level, more modern interface to CMAKE, then they'd actually be able to specify for their internal builds, set the compile options to very high warning levels, whatever they wanted to enforce for themselves, but then make those private. And that way it wouldn't leak out and break untested, unproven compilers or people that consume this library, as they seem to be concerned about. So be aware that you do have more modern techniques and constructs like target compile options, target link libraries, and that kind of thing in CMAKE. And we can use this more declarative style instead of using the style where we are manually managing a bunch of variables. So that's one of the first things that stands out to me here. Now I see that this is just the top level thing, so it's possible it's a little misguided. We'll see what happens as we dig in further. We also don't see here at the top level any kind of indication which version of C++ they actually require. So we're going to have to dig down and see that. And it looks like the CMAKE / fprime.cmake and fprime-code.cmake are files that we should be looking at. And I also just want to kind of point out the CMAKE current lister. I'm pretty sure that that is just unnecessary, but that's fine if you want to be explicit about it, I guess. So let's go ahead and dig into the CMAKE and this fprime.cmake. So yeah, here we go. Include directories versus target include directories. And building a set of dependencies, that's more of a modern CMAKE thing. I did not set out to make a reviewing the CMAKE code here, but I've been spending a lot of time looking at CMAKE lately, unfortunately. So just something to think about. All right, so we don't see any actual like add executable or anything like that in here yet. Okay, so when we get down into more specific targets, they are enabling -w extra at least, but then disabling unused parameter and no long long. Now, -w all, -w extra, again, it's a good start, but really doesn't have anything at all to do with catching all the warnings that a compiler can these days. Dash standard equals C++ 11. So again, they're using this variable management instead of using the more modern CMAKE idioms, where you would have use target compile features to say that it requires C++ 11 or something like that. And then CMAKE automatically sorts out for you exactly which flag is required on the particular compiler that you're using. Now see, this says new in version 3.1, so it's not exactly brand new, and I believe they require CMAKE 3.5, so they could definitely be using these features. All right, that was Darwin. Let's just dig in a little bit on, let's see, Linux Common. I don't see them add any extra kind of warnings on that one. Here, these things look pretty much like they're just including back the other flags. All right, that's probably enough time on CMAKE. I think you get the idea. If you want to, by any chance, go back to my book here. There's a couple of comments on here in chapter 5. I dig into some more into some of the compiler warnings that are available to you and some of the static analysis tools that are available and how to enable static analysis with CMAKE and that kind of thing. And you can also check out my C++ starter project, which has a whole lot of CMAKE in here that goes into like actually enabling tons and tons of warnings. And I try to use modern best practices for CMAKE. Here, there's still some stuff that probably needs to be cleaned up and some sanitizers and static analysis. I might have to do a checkout of this code at some point. We'll see, but I don't see any kind of sanitizers support in this. And sanitizers are super helpful for catching real bugs. Undefined behavior sanitizer, address sanitizer, absolutely amazing. And I do go into those also in chapter 7 of the book. So something to think about. All right. I don't even know. Let's see. Where do we start? Let's see. Where do we start? In this fprime code, it adds subdirectories. Let's see. If testing is enabled, we want to use stest. Well, they use a testing framework, Google Test. All right. Very good. Autocoders. Sure, let's dig into autocoders, then maybe FW, and we'll see what we find. Autocoders. Okay. It looks like this says Python, autocoders Python source. Oh, goodness, interesting. It's some sort of code generation tool. Oh, wow. I am not going to dig into Python, but it appears that a fair bit of code is being automatically generated somehow. That is interesting. Let's get out of there and get back to the things that are C++ in here. Although I guess I'll dig back in real quick and see if there's C++ in here. Nope, that's Java. All right, let's see what FW is. Okay, this is a fairly sizable subdirectory. The buffer com, let's go into buffer. We'll just start at the top here. Hey, look, we found some C++ code. All right. So it's got some sort of micro testing in here, something utest. I read that as micro test. I don't know if that's what it is or not. Uses gtest. We've got some C arrays, whatever. If, you know, testing code, I feel like your testing code should still look like real world code, and maybe this does, but there's not a whole lot to see here, it looks like. Let's go ahead and dig into the actual C++. All right, we're in our first actual HPP file. And let's see, no undefined behavior in the include guard, so that's a start. It's actually very common for people to have undefined behavior in their include guards by using double underscores and that kind of thing, which I've done episodes about on this channel in the past, including a few headers. If FW serializable to string, okay, then fine. All right. Namespace, FW, buffer inherits from serializable, okay. An anonymous enum inside the buffer, sure. All right, we've got construct a buffer with no context or no data. If I see a comment like this in code that, you know, says like this, assignment operator to set given buffer's members from another without copying wrapped data. Without copying wrapped data. That's interesting. How does it not copy the wrapped data? I guess it's some sort of copy on write, perhaps, mechanism? I don't know. But it does make me think, okay, like, do we... Yeah, I guess these do need comments if they're saying they don't copy some aspect of the data. Assignment operator and comparison equals comparison. There's a lot of documentation here. Nothing that immediately jumps out at me, although probably this is a situation where you're not using exceptions. I'm guessing if they do use exceptions, what I would really like to see these functions have no except declarations on them. We saw that it requires C++ 11. So if these things had no except on them in the cases where it was correct for them to be no except functions, that would make it more clear that that was the plan. And it looks like, I mean, we don't know what this serialize repr thing is, but we've got pointer to the data, size, and context. I mean, it looks like a pretty standard buffer kind of thing. So yeah, probably most of this can be no except. Nothing's immediately jumping out at me that makes me go, oh, this should definitely be const expr. Although, I guess, no, because this inherits from serializable. I wonder where serializable is actually defined. All right, I've gone ahead and opened this in CMAKE, hopefully to make navigation of the code a little bit easier, although I am missing some Python dependencies, so I'm unable to configure the project. But let's still hope that we can actually explore the C++ code a little bit more easily. So we were down here in the f'FW folder earlier, and I started right at the top and I was looking at buffer, and it seems to have been able to parse this code. Here, let's see if we can get to this serializable. Cannot find declaration to go to. FW types, because it wasn't able to configure the project, but it'll still give us a little bit of an interface and some search capability here. I probably should have gone through and actually gotten this to configure first, but I was hoping to just be able to browse this thing a little bit more quickly here. So serializable. Let's look at serializable. So using typedef enum, this is not C++. This is C, just for the record. For declaration, no big deal. I find this interesting. The descriptions, let's see. All right, that's, yeah, for declaration. Using pure virtual functions. Let's see, we've got a virtual destructor here. Now let's see what the virtual serializable destructor does. Okay, it does nothing. So the virtual destructor and the default constructor both are empty. So both of these actually could be done as equals default, and then it makes it clear to the reader of the code that we're not actually doing something special in our code. And personally, I wouldn't have a comment that says destructor or default constructor, because if you're programming in C++ at all, then you know what those things are. And I'm guessing serialized buffer base is similarly just an empty destructor, and in fact, it is just an empty destructor. All right, I couldn't handle it anymore, so I went actually and just installed the pip packages that I needed, and it was really no big deal. I just had 3 packages to install, and now I can actually browse this code in a reasonable way using CLion. And it's interesting to see what things CLion warns on. So operator equal should return serialized buffer base. Yeah, absolutely. It's very strange to return a const reference after doing an assignment. That is not the normal thing to do here. And, you know, to be fair, we can just hit F2 a few times. It's interesting. This is kind of C-ish, C++-ish. We've got these virtual destructors. Excuse me, we've got virtual functions. But to pass explicit void parameter in C++ is a strange thing to do. And clang tidy warns on it, which says to me that they're clearly not actually using clang tidy to do any static analysis. Otherwise, they wouldn't have this code in here. But at the same time, it's not really harmful per se. It's just unusual to see in C++ code. So we've got a bunch of those. They're not big deals. What is this? Not implemented. Okay, so very interesting. These are single parameter constructors. This isn't disabling the copy constructor. This is disabling something entirely different, actually, in fact. This is requiring that the thing that you would, quote, be copying from is a non-const object. And if you've got const correctness throughout your code at all, the probability of this function being fired here is extremely low. What they wanted to do in C++11 is this, and then they just say equals delete here on this function. And you don't need to make it private. This is a C++ 98 kind of idiom. This code was written in 17. We can see that with the blame that we have here. And trying to disable copy via a non-const pointer, I'm extremely curious why this ever came up. And if you really thought you needed to do that, maybe you wanted to do this, but a pointer is never going to implicitly call the copy constructor. I'm truly would be shocked if this code is actually being called anywhere. Beyond shocked, actually. I've never seen anything quite like that before. So that's probably dead code. But that's all right. I mean, you know, these things aren't really big deals. It's just unusual. And so, yeah, we can delete that. And I'm just going to now, at this point, we've got the ability to browse our code. This is cool. And so it's easy to come back to these things. We already commented that these things should just be equals default. Almost certainly, there's very little reason to ever define them out of line. But at least they have this. Now, they're not following the rule of 5 or the rule of 0. Now, they've got virtual functions here, so they need to have their virtual destructors, and they've kind of got this kind of C++ 98 thing going on with disabling the copy construction, but again, that should be equals delete here. And they probably should have followed the whole rule of 5 and disabled the assignment operator, move assignment, copy constructor, and move constructor. And as long as we're going to go back to my book here, I do have follow the rule of 5, and then if you must do manual resource management, follow the rule of 0. If you must do manual resource management, follow the rule of 5. That's going to come up here where you've got virtual functions and you need virtual destructors. Both of those things are going to be explained in the book. All right, do we see anything else of note here? I'm going to use my handy built-in clang tidy analysis. That is fascinatingly weird. Have an assignment from a const character pointer. That's not unusual for something that is string-like, but then to return back a const character pointer instead of a non-const reference to self, like we're also getting this assignment here, I would like, this is the code that I would love to see a comment on, but I don't. It's just written here like this was the expected thing to do, and this is the surprising code. Now let's see, copy constructor doesn't make sense in this virtual classes. There's nothing to copy. Okay, derived classes should call the empty constructor and then call in their own copy function. So that comment here is, and then this is a link to the rule of two. So I see here that they've actually done something here to tell that LGTM tool that they're using to ignore this code for some reason, and I don't know why. I'm almost afraid that this LGTM website is actually kind of making them go astray a little bit here as to what is commonly accepted modern best practices here. Let's see if we can dig into, they've got their own assert thing, whatever, that's fine. All right, so that's the types thing. We were coming from this FW. Let's pick, like, I don't know, one more random thing here. Object. I see base classes like all over the place, which I'm curious about. So this is a base class, but with virtual functions, but no virtual destructor. So this is one that almost certainly should have a virtual destructor, and your modern compiler would warn on this, particularly if you were using it in a way outside of the normal scope of things, if you had extra warnings enabled that you were trusting. So yeah, so just for the record, oh, there it is. There's the virtual destructor. Okay, good. And they made it protected, which I have absolutely no problem with that at all. Now this, we see a highlight under here that this is a single argument constructor. This is going to give a converting instructor, possibly a bunch of accidental conversions are happening here from const character pointer into this object base thing, although unlikely since it's a protected constructor. So it would be more interesting to see where this is actually being used. Here we go. Port base. All right, so this derives from object base, and it's passing in 0. Now, 0 to something expecting a pointer, this should definitely be null pointer. And you know what? Clang tidy is doing the hard work for me here. Definitely covered in my chapter on using static analysis. Yeah, use equals default to define a trivial destructor. That's, again, the analysis is telling us that. I'm honestly a little surprised that we don't get more compiler warnings. I'm guessing if you compile with -w pedantic, which I always recommend, then this would actually become a compiler error in this case. C++ has never required void for an empty parameter, and it's inconsistent because the default constructor doesn't have one here, but then the destructor does have one. So, pick a consistent style. This is interesting. So explicitly ignoring the return value from snprintf. Well, why was that necessary? So snprintf, yeah, we're not going to get any real info there. Now, as usual, I'm using the awesome cppreference.com here. And let's see, what's the return value? Let's see, the return value, the number of bytes that would be written, not including the rule. Okay, that's in the case. Returns the number of characters written so far by this call to the function. So for some reason, they had a compiler that was generating a warning for them here saying you're ignoring the return value from snprintf. It's probably actually important to know if it failed or what it did. And that's being ignored here. So any cast, particularly a C-style cast like this, I would say is a warning flag. But also we've got maybe unused that can be used in C++ 17. It's a C++11 code, so they wouldn't be able to do that here. And being that they only require C++11 also, then a lot of this code couldn't be constexpr, where I would normally say this could be constexpr. I see the squiggle here from clang tidy, or no, actually this particular analysis is coming from CLion itself. Expression can be simplified. You could just return imcon object equals 0. No. Imcon object not equals 0. You know what? I'm all right with this thing returning explicitly false or true. I'm also okay with having used an inline lambda here instead of a ternary expression. We're starting to see the same kinds of warnings pop up over and over again. Reinterpret cast and a log message to a U64 from an object of type object base. So passing in, this is an array, passing in an index is going to return to us a reference to an object of type object base, and then they're doing a reinterpret cast. I don't know why you do that. It's only on a log message here. It's almost certainly still undefined behavior, but probably not causing a problem. Any reinterpret cast is going to make me nervous. Now that I see one, now I feel like I have to do a search. Oh, okay. All right, okay. All right. Let's see. Okay, no. All right, that's all in documents. Okay, good. Let's ignore the stuff that's in documents. 5 occurrences here. Log messages. I feel like if this was really necessary, you probably could have written a wrapper that takes these things of this type, a variadic function wrapper perhaps, and then does a hidden reinterpret cast. Really making me nervous here. Let's see, this is a reinterpret cast of a sock adder pointer from sock adder in. Let's take a quick look at this, because this is one of these questions involving like how do we work with C libraries in these kinds of cases. So sock adder in is its own type. So I think this is something coming from C. It's coming from the sockets library. Might be the only choice here. Yeah, this is all socket.h stuff, so that's probably okay. I would definitely run this code with undefined behavior sanitizer and address sanitizer just to see. This is a void pointer and you're doing a reinterpret cast here. Technically, only a static cast is necessary, although it's still going to accomplish the same thing. We have to raise the question of, though, why are we getting a void pointer to our read task? We already see that they're using virtual functions and inheritance everywhere. Why not make this a pointer to some sort of base class or use a more type-safe library? We don't really know a lot of the architecture here, but it would make me ask questions. And again, static cast is technically okay here. They're both doing the same thing underneath. Because you can static cast a void pointer to any other type of pointer type that's not a function pointer type. Yeah, that's probably okay, although that makes me nervous too. It's type def for pointer cast to a U64. Nervous about that code. Ooh, I like it. So there actually is an assert cast, which is a reinterpret cast to the pointer cast. So this is a pound to fine that they could have used in those other cases. And so at least you wouldn't see reinterpret cast everywhere, but it would still be everywhere. Oh, and look, and we happened to pop down into here into another code where we could have used equals default. Yeah, you know, Just for the record, because I know someone's going to say something about it, I'm not trying to give this code a really hard time. I'm just searching through the code and I'm seeing what we happen to see. This reinterpret cast of a U8 pointer to a const car pointer, that's probably fine. That should be fine. Yeah, because you're allowed to use a reinterpret cast on any type of object to view it as a character pointer. So character pointer, const character pointer, and byte pointer are special. They have their own provisions in the standard for these kinds of things. Reinterpret cast between any other two unrelated types, though, is always undefined behavior. That's why it makes me nervous. Having undefined behavior in the code is just, it just makes you nervous. If there's undefined behavior, then all bets are off. You have no idea if the code is valid or what the compiler might be optimizing around or anything like that. That makes me think of something. Okay, we don't see them limiting. I was just doing an odd search here to see if we saw like, can't use -os because it breaks our code. Definite red flag. Oh, look, here's another use case for null pointer. A considerable portion of the things that I'm pointing out could actually be fixed up with clang tidy's C++ modernize things, and it would just go through and just fix these things. And there wouldn't be a whole lot to talk about, honestly. Although I feel like a really good audit of all the use cases of reinterpret cast would be warranted at this point. The rest of the code, I feel like, well, I mean, obviously we know this is proven flight-worthy code that's been sent to space. So I don't expect that there's any real problems here. Although this is bothering me. This is really bothering me. I don't know why they have this code right here. That it's very interesting and somewhat troublesome to me. But it is, just a modernization sweep and reinterpret cast audit, I think, would be very good ideas here. And then I would want to just, ask, like, is the inheritance that you're using necessary? Are there other ways that we could have done these things? This serializable, that's handy. It's probably where a lot of these reinterpret casts are coming from because they're just trying to serialize out the things that are in here. And for trivial types, that's doable, but it's not necessarily portable and something that you'd have to take great care with. You can take a trivial type and you can copy all the bytes out, and then you can copy them right back into the thing and have that object again. That is definitely legal in C++. You can't reinterpret cast it. That's definitely illegal. And a lot of these small functions, I would just inline them into the header file. I'm looking at the subtract function here, and I'm wondering why these are non-const references. Yeah, those should all be const references. So that is, well, to bring it back around to my book, one of the main things that I've gotten here is prefer const expr. Let's see, const everything that's not const expr, const everything known at compile, const expr everything that's known at compile time. There should be more const usage throughout this code base. Idiomatic. Let's start to make a list. All right. Idiomatic operator overloads, more const. We want to consider but we're greatly limited by C++11. We need to do an audit of all reinterpret cast usages. We also want to do an audit of explicit cast to void. That one has me a little concerned. We want to follow the rule of 5 for sure. We want to inline and default our trivial constructors and destructors. And I don't mean inline as in the keyword, I mean move that to the header file. Definitely want to enable more warnings. Remove the void parameters, and I say this mostly because there's a lot of inconsistency here. And remove that inconsistency. Yeah. I'm going to say more const twice because there's definitely use for more const here. And what else did we keep running into? I think that's pretty much it. Yeah, like this idiomatic operator overloads. Did I say that exactly? Yes, I did say idiomatic operator overloads. Oh, right. Right, we want to do equals default where we can and equals delete where we should, instead of this hiding the copy constructor, which we used to do before C++11. Yeah, that's really the things that we see come up over and over again. Oh yeah, that's right. We definitely want to use clang-tidy's modernizer and pick up on this null pointer usage. Using null pointer instead of 0 is going to make sure we're actually doing the things that we mean to do in the places that we mean to be doing them, really. And I think that's a pretty important thing to do. This arrow is not necessary, but whatever. I'm not going to give you a hard time for it. I just wouldn't do it in my code. Yeah, same thing again here. And this is kind of common when you're doing code reviews. You end up finding like the same 5 or 6 things that are done consistently throughout the code base that are actually relatively easy to clean up. I mean, we see it again right here, this non-idiomatic assignment operator. If there's a reason for this, then we got to have a comment on it. Why is your assignment operator? And yeah, this says equal operator. I'm just going to go ahead and call that the assignment operator because it's not the equals comparison, equality operator. And, you know, we kind of have this in the C family of languages, a little bit of confusion here. So let's be clear that this is the assignment operator. But yeah, that's, you know, basically what I would do in a code review. Although, of course, if I'm being paid for it in more depth with more formalized documentation written up. And these are the things that we found. And many of these things, like I said, it can be followed right here in my C++ best practices book, which I'll be sure to have a link to in the description for this special episode of C++ Weekly. I'm going to go ahead and shut it down here. I've recorded an hour worth of material. I'm guessing this is going to edit down to about 30 minutes. So I hope this has been a good episode. You learned something new. And please don't think that I'm trying to give the authors of this code a hard time. I just thought that this would be an exciting project to look through and try to get some kind of idea about it. It is truly just, for the most part, very straightforward code. We don't know about this code that's being automatically generated. The scariest things might be in there. We don't know. You do need to run audits on your automatically generated code as well. That's the stuff that's really where the meat of your project might be. And that's the stuff that you do need to spend time on. Thanks for checking out this episode and be sure to subscribe.